Hello, everybody. I've been asked to do some questions from homework 94 and 96, so I thought I'd just kind of walk through how I would do those just to give you a little bit more experience there. Before I start, I just want to make it very clear. I have put this on my website, but please know that everything that you do through your website, anything that you're given that will have a score attached to it, please note that that will not go into PowerSchool. And we are not supposed to be putting in grades, but this is just a way for us to give you feedback, give you an idea of what you need to work on and what you know and what you're doing well. So anything, even those quizzes yesterday that you turned in, or the day before, whenever that was, those are not going to be put into a grade book. I just kind of emailed you back with any feedback that I had. So please keep that in mind. Don't stress about this. Just try your best to keep up with the material so you know it. All right, so I'm going to start with 94, which does, yes, look quite intimidating when you see it. That looks busy. So remember my advice in starting with the most complicated side. I think we can all identify what side looks the most complicated. Remember, algebra is an incredibly important tool when you are trying to do these proofs. So I'm going to look for opportunities to use algebra. And it seems here that I have two terms here, all of this stuff plus all of this stuff. And within each of those terms, I have two things multiplied to each other that look to be like binomials. They look awfully a lot like a binomial. I have two terms within them. So if I go back to what I would normally do in an algebra class, I would start by multiplying this out. First times first, outer times outer, inner times inner, last times last. Foiling, if that's the word that you were taught when you learned that, or simply distributing. So that, if you look in my notes, that's what I did first. So I'm going to do that again here for you. Again, first times first, that's going to give me tangent of alpha. I'm not going to make my alphas all fancy. I'm just going to write it like that. Minus, I'm going to multiply, let's see, tangent A times all of this. So I have tangent A, cotangent beta. Okay. Then I'm going to take tangent B and multiply it to the 1. So that's plus tangent minus, and then I'm going to multiply that all out. This is going to look worse before it looks better. So that is all of this multiplied out. So of course I'm going to now go to my second term here and do that same thing. I think I'll just start on the next line here. So I'm going to multiply the cotangent alpha by 1. I'm going to multiply the cotangent alpha by negative tangent alpha tangent beta. I'm going to multiply the cotangent by 1 and the cotangent by tan alpha tan beta. Okay, remember, I'm not going to write equals 0 here because I don't know that that equals 0 yet. That is what I am trying to prove. That is what I'm trying to show. All right, so now I'm just going to take a look at what I have and see if I can do anything with it. And I notice, I can't do much with tangent alpha by itself, but right here, if I multiply a tangent alpha times a cotangent alpha, seeing as how they are reciprocals, multiplying two reciprocals results in just a number 1. So this actually is 1 times cotangent beta, so I'm going to leave that. Even though these are not written right next to each other, I see that same thing happening right here. So these two multiplied to each other would give me a 1, so I can cancel that out. I see it here as well. Cancel that out, times tangent beta. And again, I got it going on right here as well. So, if you'd like, you can clean your work up now from there. Or you can leave it like this, really, if that's okay for you to see. But I'm gonna write over again, just because I'm trying to be very thorough here, what I have left. So I have tangent alpha minus cotangent beta plus tangent beta minus cotangent alpha plus cotangent alpha minus tangent beta plus cotangent beta minus tangent alpha. And you're probably probably seen where we're going with this now. I have a lot of things that I can cancel out. I have a positive tangent alpha and a negative. Negative cotangent beta, positive cotangent beta. Tangent beta, negative. Negative cotangent alpha, positive cotangent alpha. Guess what that equals? That equals 0. So I am good to go. I can put a check mark or my QED or whatever, but I have proven that that is equal to 0. Just took some algebra and a little bit of identity knowledge. All right, so let's look at 96 while we're here doing stuff. If I look at 96, similarly, I see some stuff I can do on the left side. The right side isn't as nice. Sorry, I ran out of space there. I was trying really hard not to, but I still did. I'm going to try to get it equal to this when all is said and done. So I'm going to take this and do what I can algebraically to it. If I have two things subtracted that are squared, of course, I can multiply that out. It's kind of like foiling as well. So I'd have sine squared alpha minus, of course, don't forget that middle term, my biggest pet peeve, 2 sine alpha cosine beta. If you don't know where this came from, then you should write sine alpha minus cosine beta squared as sine alpha minus cosine beta times sine alpha minus cosine beta, and then multiply out, plus cosine squared beta. And then I'm going to take this looks just like our last problem. I'm going to FOIL that or distribute that, multiply that out, so I get cosine squared beta minus, we'll say cosine beta sine alpha, plus, I'm going to do this now, it's going to be sine alpha cosine beta minus, do that now, sine squared alpha. All right, looks a little nicer. Let's see if there's anything that I can do to this that might make things look a little better. What do I see? I see sine squared alphas and negative sine squared alpha that I can cancel. I don't see anything else that I can cancel. Well, I could combine though these two. This is a negative sine alpha cosine beta. This is a negative 2 sine alpha cosine beta. So I could combine that. Let me make sure that is what I have. Okay. Can't do that, but I can combine those. And I also have another sine alpha cosine beta. So actually, I'm going to cancel these out just to make this easier. A negative 1 sine alpha cosine beta, a positive 1 sine alpha cosine beta. That is something I can cancel. Didn't recognize it because it was flipped, but of course we can do that with multiplication. So I'm going to cancel that out. I'm going to combine these two like terms, and I'm going to get negative 2 sine alpha cosine beta plus 2 cosine squared beta. That's what I have now on this side. Take a look at what you're trying to get. I see that I'm kind of getting there. I've got some cosines, I've got some sines. Everything seems to be taken of the correct variable. That's all looking good. But of course, the next thing I'm going to do to finish this up is going to be to factor out what these two have in common. So I'm going to take a negative 2 and I'm going to take a cosine out, which would leave me here with a sine alpha and would leave me here with a negative cosine beta. And there you have it. I've done it. And so that is that. Okay, so I hope that helped. Please let me know if you have any other questions with the homework. I have adjusted the website a little bit just to allow for some more room and some more time for you guys to get through things. So if you've looked ahead, you might want to look ahead again just to see the adjustments there. But please let me know if you have anything. All right, I will talk to you guys later. Bye.